Hi, I'm Michael Pfeifer. This is another episode of Metal Conversations. Today I'm going to talk about my perspective towards looking at a product. So when I look at a product, I see many different materials that have been modified and manipulated and shaped into different components, and all those different components that have been brought together and assembled into a product. And this perspective applies to all products. It could be a bicycle, hand tools, appliances, automobiles, bridges, um, uh, medical devices, and so on. Anything you look at, you can see that it's different materials have been modified and manipulated and shaped to make the different components that are in that product. And this perspective, I think, is important because it helps me understand the relationship between the engineering of the materials and engineering of the shape and form of a component in order to meet the requirements for the product. Also, it also helps me understand that for any product, its performance, reliability, and cost depends on these individual components that have been shaped and manipulated and modified and made out of different materials. And it's the engineering that goes into engineering both the shape and the form of the component, but also the materials that will be important in order to optimize the performance, reliability, and cost of those individual components. And I think a lot of people miss that. They focus on the mechanical engineering aspects of the component, thinking about its shape and the features and the dimensions, and don't think so much about the materials and how to engineer the materials. Now, I'm a metallurgical engineer, so I'm focusing on metals, but really this applies to all materials, metals, polymers, which means different plastics and adhesives, also rubbers, and also ceramic materials. And then, of course, the semiconductor materials, if we're concerned about semiconductor materials, and then all the materials that are used in making joints between components. It can be solders and brazes and weld filler and also adhesives. So when we're looking at all the individual components, we can engineer both the form and the materials. So for metals, what can we engineer? Well, we can select different alloys. So for example, for steel alloys, we can select different carbon content, can select different alloying elements to add to the steel for modifying strength and other properties. Also, we can specify how we want to order the material from a mill, from a steel mill. So we can order the material in the hot rolled condition or in the cold rolled condition or in the fully annealed or spheroidized condition. And those different conditions, in addition to the composition of the alloy, will influence the properties and the performance and also the cost of the material before the material is shaped into whatever shape we want to have for that component. So we can also engineer any coating that we want to put on the material. So if you want to use a lower cost base material such as a carbon steel and put a coating on it to give it good corrosion resistance, that may be less expensive than using a stainless steel uh, alloy by itself without any coating. But we also have to think about how is it the ease of fabricating the material into the shape of the component, because some materials are easier to fabricate using specific processes. For example, with steels, some steels are easier to machine than other steels. Same goes with stainless steels and other alloys, and also welding. Different materials have different degrees of ease of weldability. And we want to make sure that when we're selecting the material to use for a component, that material is easy to shape into whatever shape we want it to have, but also that it's easy to join that component to other components. And there's going to be trade-offs between the materials and the shape when designing components. And that's great when we do that. And the important thing to think about is to be able to try to come up with ways to optimize both the form and the materials in order to meet the performance and reliability requirements of a component at the lowest possible cost. And I think that when people, if they start looking at the product as being an assembly of materials that have been shaped and modified and manipulated and engineered, then they might uh, look at designing the product in a different way and not just think about, well, I'm just joining this mechanical part to this other mechanical part and thinking only about the mechanical aspects of it, but also thinking about the materials aspects and the engineering the materials. An example I have for this is a bolt. So if you think about bolts, they're used in a lot of different applications. Bolts are used to hold things down or to join things together. A bolt might be used in a bicycle crankshaft to hold the crank, the arms of the crank um, to the gear. Bolts can be used to hold a table down to a floor inside of, let's say, a cafeteria, or bolts can be used to hold different parts of a bridge together. And for those different applications, there's going to be different designs of the bolts, both in terms of the size of the bolt. So for the bicycle, it may be a smaller length bolt, maybe smaller diameter. And then for the bolt to hold down a table, it might be a larger diameter, larger length. And then for bolts used in a bridge, it's going to be even larger diameter, and will be longer. And then also they can be made of different materials. We want for the bridge to have very high strength bolts, may have be a carbon steel that's been heat treated to get high strength, and may not need as high strength for the table and the bicycle application. Also, the different applications have different corrosion requirements, and so might use different materials based on the corrosion requirements, or use coatings to help prevent corrosion. So that's just one example of how one component can be engineered in different ways for the different applications. Um, Now, for many products, there are many components inside of them, and perhaps not all components require the same degree of scrutiny as others. And if we're looking at ways to innovate or to reduce costs, sometimes it means focusing on on components that have the most opportunity for or for, I should say, reducing cost. Or if we're looking to innovate, looking at the components that have a big impact on the performance or reliability of a product, and finding ways to improve the performance and reliability for those particular components. And then focusing and then moving down to other components that that might not have as much impact, or just neglecting them altogether, and just doing selecting common materials and and doing the engineering on those, and not putting as much engineering into that as with other more impactful components in the product. Um, so I think that this perspective will help people identify opportunities to innovate and to reduce cost if you start looking at components as being more than just a, a form, a thing. It's really materials that have been manipulated, and start looking at the product as being an assembly of all these different materials that have been engineered to make the components to that go into that product. Thanks for listening. If you have any questions or have comments, please email. My email address is mike@imetllc.com. Love to hear your comments. Thanks for listening. Bye.